Hi there, I'm Sarah Wheat, and this is Lab 505, Motion of a Thrown Ball Analysis. For this lab, we were given freedom to choose what we wanted to discover within our physics that we have learned, and I have chosen to analyze a ball that has been thrown up and has fallen back down in a bell curve style of motion. I wanted to track and compare my predicted data and my observed data using Tracker and a GlowScript code that I have written, and I wanted to be able to use or calculate out the energy changes and also determine how much force my hand has applied to the ball. On the right, I give it a graphic of as the ball is ascending to its maximum height, the force of my hand and the force of gravity that acts on it. And then as the ball is descending, you have to account for the drag force as well, that is in contrast to the ball's falling down style of motion. So for the physics principles, like I had said previously, I went with the energy principle, and I have K trans and my potential gravitational energy, and the sum of these two, which is my total energy. I have Newton's second law, which is the two equations we've been working with all semester that include your final and initial position as well as your final and initial velocity. I had calculated out some initial data of my gravitational constant, the mass of my ball, as well as the drag constant, which I had found to be 0.45 for a decently close constant. And then I also have an image of what my tracker analysis ended up looking like for the motion of my ball. I ended up, after graphing the two graphs, on the top I have my graph based on Tracker, and on the bottom I have my graph based on GlowScript, and I was really confused as to why they did not look similar. And then it occurred to me on how, based on Newton's principles, the force of my hand is not applied over the entire motion of my ball. It is actually only applied in the very beginning of the motion of my ball, and therefore I cannot be trying to account for it in the total motion, otherwise it wouldn't end up working out that way and it would not make sense. And so I did have on the right the code that I had written out and used, which I ended up editing in the future to see what has gone on with my code. So I now discovered that F hand is only applied, like I said, at one point, and then I instead have decided to actually track my data in the decreasing motion in order for me to get two similar style of graphs, and I edited my code to do that by including the new initial time and the new initial velocity. I only wanted to go from the top height to all the way from that point, which is about 0.433 seconds in, to the final point, which is about 0.8 seconds in. And then I will actually be using some tracker data that I had gathered to record my final initial velocities based on Newton's second law, and I'll use the energy principle to calculate out with all those three the force that my hand applies to the ball. But I will be wanting to use only the first half of the motion for this because that is the different period in which I will be calculating where the force of my hand was in effect. So just to contrast, I ended up changing my data, so I only looked at the second half of my motion where the two graphs are now much more similar. The predicted motion is obviously much straighter because it doesn't have the human error that is taken into account in my tracker data. And now when I want to calculate my F hand, again I'm paying attention to the first half of my data when it reaches its max height, and I'll be using these four equations like I said previously down below. I went in and I calculated out the delta E total, but I only calculated it out in the Y direction, and so I have that there should be an equal change in energy over the difference traveled by Y, but there is another force that is being applied here, and now F hand is applied in the X direction as well, so we need to slightly modify these results by using Newton's second law instead of these energy changes, which I have done here. And as you see, I have calculated out going backwards from my position equation to my velocity equation to calculating out F net, and then F net I then have calculated through F hand, and I got my F hand to be what is shown below in pink, which makes sense due to the fact that I did throw the ball in a little bit of a negative X but a positive Y direction in total. And in conclusion, this lab has been able to show me how it's helped me realize and see more of the actual effects of what these laws are being applied in the real world, and how in physics you do have to sometimes modify your objectives or your goals to be able to get accurate results. And thank you for listening.